Good afternoon, everybody. It is March 14th, and this is only the second time today I'm going to say this. Pi Day. I know, it's a little cheese. I get so many memes and shit on Pi Day from everybody that thinks, oh, he's a math teacher. He wants to have this, be inundated with it. It's March 14th, 2022. Today, this is Computer Science 1, Introduction to Programming. And we are covering an introduction to pointers and references and stuff. So I made this long, nice little presentation, and we're just going to go through it. And I've got it commented out, so we'll put some comments on and off. But pointers are a lot about saving time and space. Maybe I'll just start with this. I'll run it, and we'll show what's going on. So right now it's let me maybe narrow this down so I can have some more room. So my first thing I did is I assigned shit. Let's reduce that down. Let's do that. There we go. I set a variable integer to x equal to 10. And then what we do with it when we have a pointer is we put a star after the data type. And what we store in pointers are addresses. And that's what the ampersand does. The ampersand x says, what is the address of x? So that's what I store in y. And we'll look at the z in a second, but let's just look at what that says at the top there. Value of x equals 10. It's saved at x's address in memory, which is in hexadecimal. And then the value of y is a pointer, and I'll do this pictorially in a second. And notice it's got the same address. This matches this. So y is showing me where x's data is stored. And y, of course, now, since I declared it as a variable, it has its own location in memory also. And if I'm using pointers and I want to get back what it's pointing to, we use the star in front. So we declare a star afterwards to make it go after, and we put a star in front. Right there, I have it right there is where I'm calling it. The star in front it's called dereferencing it. So let me show pictorially what I was thinking of. Maybe I should do this. There we go.
So is that like physically the register address of
Yes.
the section of memory that's stored in?
That's the section. That's exactly it.
Okay.
So we've got x equals 10, and what I'm doing is got something of size. This is my x. 10 is stored in it. And it had that long address right here. And then what I did is I made y pointer. It actually takes up a smaller bit of memory. It has its own address. But what's stored in there is this value right here. X's address is right here. So when we call on y, like any reference to y, when we use y, what that's doing is it's pointing at this memory location. And it's telling me where it is. Well, I guess there.
Now, is this like memory like in RAM or is this like storage?
I want to say it's RAM. I don't think it goes beyond RAM unless it needs to.
Okay.
I will double check that though. And then if I want to get the value stored there, we dereference it. by doing the star in front. It's kind of like inverse operations in math. You know, square and square root.
So the star Y or the dereference Y just says, hey, read the value that's at this address.
Correct. And we can actually use that when we're programming. We can actually make stuff that way. I did want to show you what happens if you make another pointer equal to a previous pointer. So here I made a new integer pointer, z, and I set it equal to y. And so you would think like y gave me address of x. If I try to do, I'll do address of y in a second. Let's see, we'll see how that changes. But setting z equal to y is just basically making 2 pointers. So that z part, if I bring up my picture, where's my picture? The z part said, oh, you want to have another one? We'll call this z then. And we'll put x's address in here too. And now y points to it, and z points to it. Now, the best, the clearest way, well, it's not exactly the identical, but a handy way of picturing like this. People like, why do this? Oftentimes is when we're passing it to other things or using functions, something like that, or someone else has to use it. They don't want to copy all of our stuff. Like copying x equals 10, that's a small bit of memory space. But what if, say, I was Netflix? What if I wanted to have all the movies that Netflix has? I want to watch all their content. Or, let's see. Who's got, HBO has, The Homelander, right? No, that's Amazon Prime, The Boys. What if I wanted to own all the seasons of The Boys? Or I wanted to watch them all? I could go and bootleg them and download them, and it would take a while to download it, and it would store it on my memory, and it would eat up a lot of memory drive. Or I could just go over to Amazon Prime and watch it on their side. I'm just accessing their content without copying it. That's what using a pointer is like. You go over to that content and you're not making a copy of it. And we'll see that in a second when we're exploring it some more.
So if you didn't use a pointer and you actually use the variable, you would actually be rewriting that variable into a new section of memory.
Yes, and I'll
so with a pointer, you're just saying read the value from this section of memory.
Yes.
Okay.
So it has its own section of memory, and when we're doing it, since we're reading that section of memory, unless it's declared a constant, we can actually change that. We can change the stuff stored there, and we'll see that later on today as well. And so that you got to be careful when you're doing it. You don't want to ruin someone's stuff. A good way of doing it, protecting it, is to make it a constant value, and then it can't be edited. It changes what you can do there, but that's kind of like we can't go into Netflix and change what's stored in the movies there. It doesn't. They do choose what's there and what's not. So it's kind of like a read only if you set it to a constant. But when we have an address, we can, just like we dereferenced it for the content here, or right here, we can actually store that in a variable. And we did that right here. Value of w equals 10. And I was illustrating the value of z. Notice that z's address is identical to y's address, or what's stored in y, which is x's value there. In each case, though, the ampersand in front means find the address of, or reference. So ampersand x is like the address of x, or the reference of x, where to find it. Where to go find x. And I think picturing something as big as, if you've ever downloaded a bootleg movie, you know how long that can take. Even with a good, a VPN, it could take a little while. Streaming it, you can just start going right away, and it doesn't take any memory space other than quick random. So, like when we make these pointers, since they store addresses, it's kind of like we have a new data type that stores an address data type. But we have one for every single possible input. We can have integer ones, we can have doubles, we can have strings, string pointers, we can have char pointers. So we kind of like double all the different types of variables we can create, but they're basically choosing the addresses of other locations. Okay.
So does this speed up your program by not having to copy and rewrite that back to memory?
For big program, yes. Okay. Effectively, yes. Since like if we were my grad school work, it was I did 1,000 by 1,000 by 1,000 3D matrix, which is, let's see, 6 zeros is a million. It was a billion different squares in a 3 by 3 setup, like a Rubik's Cube, but 1,000 in every direction. A billion entries, and each entry had to, or each location I had to store density, pressure, a whole magnetic value. There was a lot of quantities to store for each location, velocity. So it wasn't just a billion, it was like a billion times however many quantities I had. Plus, they all had to interconnect. It takes up a lot of space. If I were gonna, it would eat up a lot of my hard drive, and it did when I was doing it on my own. But I, at one point, was when I was at the school, I was able to access the supercomputer, and I had it all stored there. They did all the calculations, and then I was just able to view the data there without actually downloading all the data to my computer. And I could edit it that way too, which is nice. So it's like kind of like making a blog. Like you're not making the diary on your own or the blog on, blog is a diary really. You're not making your diary on your computer. You're making it somewhere else through accessing it. It's not a copy. Let's see. So we want to put the star after the data type to say it's a pointer. And you'll see, like, let me close this. Sometimes they do it like this. And I think it's a little confusing that way, because this looks like we're dereferencing something. So it's easier to remember the other way. Notice my addresses have changed. The previous one had different letters. So each time I run this, it occupies a new space in memory. And that's what the return 0 does at the bottom. When we have return 0 at the bottom of the main, it says, all right, whatever I've allocated to what I'm going to use for this memory, deallocate it. Get rid of it. We don't need to use it anymore. Use it for whatever you want. So, like right now, I'm recording this with Camtasia, and I imagine Camtasia does not take up sequential or contiguous data. So it's just recording it where it can. It's like, okay, you're done with that. I'm going to record there now. And so this just goes for an open spot of data when we use it. I'm going to comment that out now. Actually, I want to keep X and Y in there. So I'm going to just comment on everything else. Oop. I want to put that up here. Actually, no, I want to show that X and Y while we're doing it. It might help as a reminder while we're gone. Okay, so I've commented out that section. I will uncomment this section. So we take a look at passing pointers to functions. So what I have right now is I've got my X equals 10. And I'm not actually using Z or W anymore, so I'll get rid of those. Actually, let's do something else with Z. Where's my Z? I'll put this up there. Let's change Z to say address of Y. And it gets a little pissy. It says Y is already an address. It doesn't like it. It does not like trying to make a point of like Y was the address of X. Why can't we make Z the address of where Y is? Like Inception, dream within a dream, address of an address kind of thing. It doesn't like it when we do that. So it doesn't, we will have stuff later on where we can do stuff like that when we're dealing with iterators. But for now, that's CSCI 2 really, is where you really start going over iterators. And I made well, this is all online, so I don't need to keep that. In fact, we can get rid of that since you have all this stored already. And we'll run that section and we'll see what happens. So here we're looking at passing, passing pointers to functions. I'm going to add some more end lines here. And rerun that bad boy. I don't like that. So we're looking at passing the pointers to memory, and we've got X equals 10 and Y is the address of X. So I've got unaltered integer, and then I've got alterations, and we'll look at what each one's doing in a second. I'll scroll down to the functions. Unaltered X is all we're doing is we're passing X in and we're saying double. Actually, let's go down and look at it. Let's go look at those functions. Too far. What I'm doing is doubling. Each thing just takes in the argument and doubles it. And that's how all three of these are set up. Alt int 1 and alter int 2. And we'll cover what this means in a second. In fact, I'll come up there and bring that up there so it's right where we can look at it. And we don't need that. So what we're doing, X was 10, and we passed 10 in. 10 doubles. It doesn't have a return or anything, and so it's just doubling it there. And when I print out the next line, notice that unaltered X, it's still 10. Then, instead of putting the ampersand, the and sign in front of it to find the address, when we put it after the integer, kind of like we did with the star, this is called passing by reference. So what I'm doing is I'm passing the argument by as a reference, and that means we can edit it, edit the value unless it's constant. Okay? We can't edit constant values. So I pass in X, it doubles it, so X doubled is 20. And when I do the C out, after X has been passed to a function by reference, notice that it's doubled. So when we pass by reference, it doubles it. or well, in this case, doubles it. When we pass by reference, we can alter the content. And I did the same thing with the pointer. When we pass a pointer, you have to tell it your description is you're passing it a pointer. So you have to put the pointer notation in there. And then since it's a pointer, notice I have to dereference here. I have to dereference when past a pointer. When a pointer is passed into a function. So that's what I'm doing there. And that's what that is. Like, this might look a little bit better. I wish you didn't do that. And then, oh, that might be the easier way. So that's kind of like one block. I'm dereferencing it, then I'm multiplying it by 2, and then I'm setting it to equal to the doubled value. That's what we're doing with the pointer, and notice it does the same thing. That's alter int 2 when I pass in y, the pointer y. And then I print out x. X is again doubled. Where did it go? X is again doubled. Let's do that. Right here, when I pass it as a pointer. Another way to pass a pointer is pass it the way we set up a pointer. Passing the ampersand x. That's what I did here. That's the same, because y equaled ampersand x. So that's another way of doing it, and it still requires that dereferencing. I use the same alter int 2. When I pass by reference, just the ampersand, I didn't have to dereference here. So you may think, well, why the hell would I ever want to pass by pointer when reference does the same thing, right? There are cases when doing the pointer is easier, especially when we go into vectors and iterators. So it's good to introduce now. A good rule of thumb is use references when you can and pointers when you must. Some places like to do it the way they set up their business. Constant arrays or variables. They pass by reference. And then non-constant or changeable arrays, changeable content, they pass by a pointer. And that way, when you work for that company, you'll know that, well, if I got a function that takes in a pointer, I can edit the content, and maybe I need to be careful with what I do. I don't need to go fuck up someone's bank account, right? That's the idea there. So, couple ways that we can deal with it. If I tried, well, I have to comment this out. No, I'll comment it out in a second. Get rid of it in a second. Is there any questions on that? Like how we've been doing this? So I'll come back over to my camera over here. Just to spell it out a little bit better. So to pass by pointer or pass by reference first, we have our function name, and we'll say data type ampersand, and then like the name of the content or the name of the variable we're passing in. We'll do arrays in a little bit, and it's very similar. If we pass by pointer, we'll have func2, and we're going to do the same type of thing, but now we're passing a pointer, so we do the asterisk. Here we can use arg as is. Here we have to dereference arg first. And you might find it helpful while you're coding to put parentheses around it, and you'll see why I say that in a second. When we start looking at arrays, it's like you're like, what do I do with an array? So let's take a look at that. I think we're doing strings next, though, first. So that's down below. I don't need that here. And we'll comment all that out. Where's my... Let's see. And now we'll bring in the strings. I think I can comment the other ones out too. Now we're looking at passing in strings by pointer. I put lorem ipsum there because to make it easy to type. I'm going to edit that real quick. If we look up lorem ipsum, this is a common thing to use to test text. It's basically dummy text. Where is it? Let's just generate some lorem ipsum tests. So that's a long string. I don't know how many characters it is. It's pretty long. That's going to take up a good chunk of memory. And so let's see what we're going to be doing with that. First off, we're going to string up means to do the 2-upper. Here we are doing 2-upper. In fact, in all of them, we're doing by 2-upper. And I'm going to run it first, and then we'll bring it up and show you what the difference is. Wow, maybe I do not want that long. I can't read it on the screen. It's not good for lecture content. That'll work. Let's see that one. So in the first case, I have a cout in my print string. When I pass in the string, normally, in the string, it 2-uppers all the words. And we'll look at the code for that in a second. But when we come back to the main and I just do a cout of that string, temp, notice that not all of most of the, wow, I want to change that back to lower. That threw me off for a second. We'll do that, change that back to lower on the next one. When we go back to the normal string, all the other words are not capitalized. So passing in the temporary string normally doesn't edit it. And this is just as we were doing with the other ones. When I pass it in by reference, it prints it within, it 2-uppers the words.
Is it changing the data there at that address, or is it just...
Look what happens when I do it by reference and I print temp again. So make some space here.
Okay, so that's just in the print then.
Yeah, so when we pass by reference here, it's 2-uppered in the program, or in the function. But when I print it out, it's not. But not in main. And let's go look at what I did there, since it matters. Holy sh... Okay, yeah. I'm too far to the left. There we go. So the way I did 2-upper, just so you can see. Let's get a little extra content off the screen. You pass in the array, or pass in the string. And then I did the first letter all by itself. arg0 equals 2-upper arg0. And since strings, we have that, the dot operator, I did dot size, pulled up the size, used that. And the way I did it was, I said if I'm looking at case I, like let's say I'm looking at the I right here. If I'm looking at case I, look at the square before it. Arg I -1 references the square before it, which is a space. If that's a space listed as a character space here, 2-upper the current one that I'm on. So that's how that worked. And it goes through until it gets to the last character and it stops. And so every time there's a space, it 2-uppers the next one there. I don't know, it might cause a problem if there's 2 spaces in there. I'm not sure, I'd have to check. So this is a handy way of checking for space. Another thing we could do is say 32 right here. 32 is the integer value. That's also how it's stored. So we could look for that as well. And then when we passed by reference, oh, did I fuck that up? Hold on a second. No, I sent in a pointer. So
you misspoke a minute ago, but
yeah, I did. I said I passed by reference. I passed by a pointer. And I don't know why I didn't. Something's off. What did I send up here? So here it should have been directly changing the output. Why did it not change the output in the main? Do I have these mixed up here? Let me comment this out one out and rerun this. It's tripping me out. Yeah, 2-uppered in the function, but not in the main. Why? Oh, this is why. Okay. So that's why. This makes sense. Here I made it, when I brought in the argument, I made a new string and dereferenced it. This did, okay, now it makes sense. I'm like, why did it not do it? I should have just read my code. I just made this last night. You would think I would remember it, but God forbid that happened. Elden Ring, I blame you. Right? So I dereferenced the address, the pointer. This was a pointer to an address, so it gives me the content at that address, and I stored it in a string. And so I did the same editing here, printed it out there, but this is one way to pass by pointer. You still end up making a copy of it when it arrives, though. But we passed a copy in, but that way we didn't edit the main. And then when we look at the way to edit the main, I did pass by pointer. And rather than rewriting everything as X or arg, what I did is I took the old code and everywhere there was X, I made it dereference X. And I put it in parentheses. So if you look at line 201 and let's see, 212 and 201, you'll see the only difference is I put the parentheses dereference the variable. And here I changed the variable name to X to make it easier. Notice it is not, don't do that. Doesn't work. Okay? You have to, because 0 is like referencing a position. It's telling it what position inside of dereferenced X. But the variable is X, and that's the only thing that's getting dereferenced. Only X gets dereferenced. Not individual characters. Because string is effectively passing an array, as we'll see in a second when we do the other arrays. But it's the same. That's why I said if you're going to dereference, it's a good idea, especially when you're passing in functions and stuff. Use parentheses, get in the habit of doing it. It helps you remember, first off, it will help you remember what to do when you get to arrays. Like I didn't do that up here. When I passed by reference in my stuff right here, I should have put these in parentheses and I didn't. And when I got to coding arrays or doing this stuff, I originally tried to do this because that makes sense to me because I've been lazy and not using parentheses. It doesn't work, and I had to stop and really think about it. Okay, what did I do before? And this is what you got to dereference first, then access the content in. Okay. Come back up to our code. And that's what happened here. We passed that one by reference, or passed by pointer. But I didn't make a copy within it. I dereferenced within it, and it edited the content as you can see over here. When we print in the main here, all of these have been 2-uppered as well. Okay? Is there any questions on that? I love using temp as a variable name. I do it a lot in functions. I send in arg and I use temp in functions a lot. This is not in a function, but
4K.
That is what I used. So we're going to get rid of all this stuff. Slowly trim down our list. What just happened there? Oh, it just finally caught up. I have to dereference or get rid of the decomment that. Now let's take a look at arrays. So I've got this array. I'm going to call it ARR because I'm so, creative. And if I see out ARR 0, what should I get when I do that? It should give me the first thing in the array. Should be the 1. When I do the address of array 0, it should tell me the location of it in memory. What about when I just see out the array, just the name? Let's take a look. So when I did the C out of 0 with it like that, I get 1. And this one gave me the address of 1. And notice when I see out the array by name without any reference to location, it gives me its location. The name of an array is a pointer to the first element of the array. So that's what I did here. I went through and I printed the array and I said where it's stored at. That's my print array function down below. Let's come down and take a look at them. I can delete these, don't need them now. That's all I did. I did some tabs to make it look pretty. I passed in this is just regularly passing in an array. We put the brackets in there and we got to pass in the size as well. And I said from 0 to size, just print out each value and then the location it's stored at by using the ampersand sign. So that's what I got right here in this set. And then what did I do? I said I did pass an array and then I reprinted it. Let's go take a look at what pass an array does. Pass an array takes in the array and the size, like you always have to do, size with an array. And then this is like our altering array. Maybe I should have called this alter array. What I did is I just doubled every value and then I printed it again. And so when passing the array in, since it's a pointer, I passed the array location in. C++ knew that this is location. All the addresses remain the same. 4FF818, 4FF818. I was able to change the content without changing or copying the data. Change the original content by passing an array because the array name is a pointer. So we pass by pointers, so when you pass arrays, you can change the content. And then what did I do here? I've got integer ABC, and then I said, let's set ABC each equal to 2. And we confirmed that. We printed them out. And then I did, now we're going to use our multi-return. We'll go look at that in a second. But multi-return, I pass in A, B, and C. And I can see from the screen that A is now 4, B is now 8, and C is now 16. And notice it says that it did exponents. Well, let's go take a look at that and see what it actually did. Is that what happened? Notice that this is a void function. Voided functions don't have returns. So I passed each of those integers by reference. Pass by reference so that I could return more than one or variable, more than one output. Let's say that, put that in the order that I was saying it, more than one output. So even though it says void, I passed things in by reference. Each one of these changed it. I square, I cube, I did the fourth power, and I got 4, 8, and 16. 2 to the second, 2 to the third, and 2 to the fourth. So you can return more than one thing, but it can't. It has to go back to where it came from. Now I could edit this. Let's tell it to return an int. Arg square plus arg.
Before you added the return, you're basically just grabbing that argument from the reference address.
Yes.
You're performing that function on it, and then you're writing it back to the same address. So you're not actually returning anything.
I'm rewriting
new.
The old data.
You're not returning anything new. You're just replacing the data that was there.
Right. Exactly.
Okay.
So it's like all these variables are whiteboards, unless we say constant and then we're writing in permanent marker. If we write in permanent marker, we can't change it, but everything else is good old, erasable marker. And so what we did is it had stuff. We said, nope, erase that shit, put a new value there. And so that's what's happening in memory. Memory is just like a giant whiteboard. Oh, that's a goddamn good way to say it. I impress myself sometimes. Now this says I got to go up. This was the implementation. I got to go up and change it up here. And change this to an integer as well. Learn to type, David. Put your fingers on the right keys. And now, if I don't see out anything, it's not going to do anything. See out, this is my multi-return, not as a void. I want to have a space in there. So let's rerun that. Let's close that. So I can actually technically have one return more than what I put in. I still didn't get good spacing. I should have added a space. Where'd it go? That's annoying. So it added up the sum of the things, and it stored the values all at once. It edited the values, and I returned an extra object. So you're able to return one more than you put in, but only one of them can be the official return. Everything else has to overwrite previous stuff. Pretty cool, right? Well, we could have done that with an array if we pass it that way, but you don't have to pass by an array. Let's take a look at doing that array thing though here. We worked with arrays here. I'm going to uncomment this. And maybe I can delete these, at least the multi. We can get rid of it all. So we're going to take a look at what we did. What happened here? I pissed it off. Let's try this again. Okay, so what did I do here? I set up my array. I didn't have to tell the size ahead of time, although I should have. Maybe I should have said constant size, and I've got int equals 5, and maybe said size here. But since I already said what they were, C++ figured it out. Then I made a pointer to the array. Okay, so now I've got array pointer. And you can't just say array pointer equals array. So this would not work. Oops. Keys on the right things. This doesn't work because R is a pointer to one thing. The first element in R. And now I'm realizing when I say it out loud that it doesn't work the way I did it. R sounds like the letter R. R. So what I did is I made the pointer. I made a pointer array. This is an array pointer that points to integers. And for each after that, I went through and I said for I equals 1 to 5 or I is 1 to size. Make array pointer I equal to the address of array I. And now that stores each one in there. And maybe I should do that print array again. Why don't I have a print array? Do I have a print array? Will print array take our pointer? No. Because an array pointer is of pointers. Did I make one for... Huh. Let's go through and make one real quick. So if I want to make one real quick, so I'll call this print pointer array. And when I do that, to make that happen, I have to tell it that my array is pointers. And I'm going to have to edit that in a second, but I want to make sure I go up and put the prototype up there before I forget. So let's come back down and tinker with it. I passed in an array of pointers, so if I want to see what's there, I have to dereference it. And since it's a pointer, I don't need to say the ampersand there. I should just be able to say arg_i because arg_i at this point is a pointer. It's an address. Arg_i is an address, so I need to dereference it to show it that way. That should work if I go up here and type it in correctly up here. Print pointer array. And I got to send an array pointer, and I'll send in size. Let's see, let's make it a little cleaner. I'm going to grab that real quick. Come up here and throw that in. I already have it in there. Sweet. I'll just run it. So now I'm able to pass in a pointer array. So I have this array of pointers, and so you kind of have to show both things in there. Notice that's what I did. I told it was an array, and then I told it the data type is pointers for integers. So it knows that it's looking for addresses of integer values, integer variables. And so that's what it got. And I'm able to use it just fine. I need to add this to my notes on the other screen. I like this. This is good. It's missing in the full notes. But again, to use it when we pass by pointer to get the value, I need to dereference. And if I just want to use the address as is, I can use it as is by just leaving it alone. So it's very similar to using arrays normally. Do we have any questions about that? This is going a lot faster than I thought it was. So either I'm not explaining it very well or I'm doing too good of a job. Weaver, it looked like you were about to say something. Tell me. You're the only one left.
Got nothing.
You're the only one. Oh, yeah. Ferris has to leave early on Mondays. You got no questions? You're good? Okay.
I'm good.
All right, let's look at the next section. I'm going to comment that out. And I'm not going to delete it because I'm pretty happy with it. Oh, wait. I'll just comment this whole section out because I wanted to overwrite what was in the notes. So let's close that because it's going to piss it off when I try to run it again. I will uncomment the next block. And I think that's all of the next block. So right now we're going to be working with chars. So let's just go ahead and run it. Talk about what we get. So I made a char, and since I made a char array really, so that I didn't have to do one character. I did my name. So each word or each part of my name has 5 letters. That's 10. The space makes up 11, and then the null terminator makes this size 12 because it takes up a spot too. And so just doing a regular C out of my stuff. Doing C out of 6, well, 0, 1, 2, 3, 4, 5, 6 is Jones. And I got my J right here. And when I do a C out of my string, note my string is an array. This is an array. So normally, just the name alone would be a pointer to that array. Not for char. When I do C out of my string, since it's a char array, notice it did not tell me the address of J. Can I get the address of J in there? Let's do this again and put the address of J in there. Maybe if I just do the ampersand, it will give me that. Oh, computer. Okay, I'll rerun it. There we go. Now it's giving me the address of the first character. But that's because I had to dereference it or I had to print the address. The ampersand. This didn't print out the address. It does the whole array. And that is unique to char characters. Char was the stuff that they did in C. And when they did C++, they made it part of the automatic stuff. When you work with a char array, it will dereference for you. Okay? So that's worth noting. It's a pain in the butt. It's different than everything else we've done with this dereferencing, this stuff like that. Char arrays are unique. We don't need to keep them as a char array, which is a C string. A char array is technically a C string. It's a string of char characters. What I can do is I did my name in char array converted to a string, convert C string, and it says my name twice. Why? What did I do in convert to C string? String temp, return temp. Oh, yeah, I made my own. Okay. So why is it printing twice up here? So since it's sending in a char array, I don't have to convert it to a string letter by letter, adding on at the end. Kind of like one of your lab assignments that's due tomorrow. You had to add stuff and character by character, I want to say. Here, you just say temp equals R. This is a char string going to a regular string. Why did it print out what it did up above? What the hell is going on? Convert C string, my string. That should only just change it. But it looks like it's doing print at the same time. Oh, it's jumping down to here. Okay. Why? No, it's not. I'm gonna rerun it. See if that's an artifact, a glitch. Oh, yeah, I am running it twice. So maybe I could do new line, end line, end line. That's not how that works. And I didn't do my string 0 yet, so I gotta put that back down where it was. There we go. Now it looks like what I was saying. So I converted to a string, and now it's string. I didn't actually assign it to anything in the main, though, so it's kind of like that was a one-shot, one-trick pony. The array is still a character array. That temp thing is just lost to the wind. It was printed out once. Then I wanted to show what if I make an array of strings, or array of char strings. Let's look at array of C strings. So I made 2 more strings. My string 1 says Lucifer and Telamon. This is from the Wheel of Time. The Dragon Reborn, or the dragon. Name of the dragon. And Dalinar Kholin is from the Stormlight Archive. And Dalinar is actually probably the main character, but he's not the main, and is one of the main characters. This is by Robert Jordan. If you guys like fantasy or book reading and haven't read any, one of the mains. And this is by Brandon Sanderson, who has, check this out. I'm going to show this. This is crazy. A Kickstarter going for over 28 million. It's only been running for 14 days. Within day one, it was up to like 15 million or something like that in the very first day. I know because I'm one of the backers, one of the top backers. I bought the biggest Kickstarter thing there is. Great author, Brandon Sanderson. Back to computer science. So where were we? So I made this array, or I made these things, and then I made an array of pointers, char pointers. And I called this my strings. And then in each one of these, I put in a char array. So by first inspection, this just looks like an array, a pointer to an array of chars. It's not. It's an array of char arrays, or C strings, which makes this a multi-dimensional array. Two-dimensional array. So I set my string 0 equal to my string, which was my name, David Jones. I set my strings 1 equal to Loose Theron Telebon, the dragon, and then my strings 2 is set to Dalinar Kholin. And then when I do see out my string 0, it shows me when I do see out my string 0, it's telling me the content at 0 right here, which is what it's supposed to do when I do that, even though this is an array of itself. It's giving me the entire array but like that, because it's a character array. Same thing with this and this. This line right here, though, just does the top one right there. And it's telling me where that character array is stored at in integer form rather than hexadecimal. These are all hexadecimals. I set it to be like that because maybe let's show all three. It didn't do it. Did I not click run? Oh, now it's pissed. Oh, it's doing it. I just have all these spaces in it. So it's going from 12840 up to 760, which is a difference of 120. I wish they weren't negative values. Let's treat it like subtraction. 840 minus 760 would be 80. 760 minus 712 is 48. Notice that this way I was able to make arrays of different sizes of what's in each box. So it's showing me the starting location for each term in the array, which is nice. And by looking at consecutively, I can see how big the first one is versus the second one and the third one, stuff like that. Then what did we have here? CL. I did print C string. What's print C string? Print C string is just taking in the pointer. And since it's in a pointer to a C string array, I don't have to dereference. Okay? Which is handy. Then I've got print C string array 1, print C string array 2. I'm going to comment those out and rerun this just to clear up the screen a little bit. So I've got my 3 arrays: David Jones, Luz Theron Telemon, Dalinar Colin, my three C strings. And this right here is showing up right there because I don't have a space in there now. But print C string 1 is right here. And print C string 2 is right here. So let's go take a look at the difference. In both cases, we're passing in the array of David Jones, Luz Theron Telemon, and Dalinar Colin. If we look at C string array, let's get some spaces in there so it's a little bit easier to read. When I do C string array 1, I'm passing in, I'm telling it it's an array. I'm telling it's a pointer of chars. So it's a pointer of char arrays. And I passed in the size. And I've got from I equals 1 to 0, just see it out regularly, no dereferencing. And then on the second one, I do it character by character. Actually, there we go. I do it character by character. So the I loop gets me to the row, which is the name or the C string. And then the J loop does character by character. I don't know the size of each one. I didn't pass that information in. So to do it character by character, I got to tell J to just keep going until the value there equals the null terminator. So this will run until null terminated. Print out character by character, separated by a decimal by a period. That's a math teacher in me calling that a decimal. Print out character by character until the C string is null terminated or not equal to the null. And since I did a while loop, I actually got to remember to put the J++ in here. And that's how I got that. Any questions on that? There's a lot going on today. I know this is going to take some unpacking. I'm sure people are going to want to look at the references, look at the notes online, and they are in there. That's why I knew there was a lot going on. That's why I pre-typed them up and did them rather than like making the stuff up on the spot, because that's error prone, takes some time, and good way to fuck things up. And if you don't have any questions, I think we're done for the day. All good?
Yep, sounds good.
All right. I will talk to you later. Good job on the midterm.
See you later. Thank you.